Okay, guys, number 5. Now, Yuto works in the quality control department of a large company. The time T minutes it takes Yuto to analyze the sample is normally distributed. So now we know exactly what distribution is, with mean 18 and standard deviation 5. So before we answer any question, always write the distribution at the top. So we can say let T be normally distributed with mean 18 and standard deviation 5, or variance 5 squared. Now this, just to make it clear, this is represented as mu and sigma squared, where mu is the mean, sigma is the standard deviation. Okay, now let's answer part A. So find the probability that U2 takes longer than 20 minutes. Now this is just simply probability that the variable t for the minutes is longer than 20. That's exactly what they want us to find. Now the only way to solve this is that we need to convert this entire system into the z distribution. So this is known as the standard normal. That's exactly what the normal table follows, which is normally distributed between 0 and 1. So 0 mean, 1 standard deviation. Okay, so let's check it out. So to convert it, we just say, okay, if t is greater than 20, then z must be greater than 20 minus the mean, which is 18, over the standard deviation, which is 5. And that's it. Converting this one, just tidying up a bit, smashing this in your calculator, you should get 0.4. Right. Now, one thing to note is that the table always wants it to be less than or equal, yeah? So if you're not sure how to convert it properly, just always draw the bell curve. You know, just label this part. Let's see, make it easy. Let's say this is 0.4, right? Or in this case, 0.4. What we're actually analyzing here, so let's treat this as a 0, yeah? If this is 0.4, then this part here must be the amount we're looking at. Okay, that's the regions of this part. But what you could also note is that the table only measures when it's less than or equal. So it only looks at this part when it's less than the value. So I always see this as the red region plus the blue region will always give you total probability of 1. Okay, that's the regions. All these probabilities equal 1. Okay, so in this case we have at the moment the blue region. We need to find the red region. So the red region is going to of course be 1 minus the blue region. Okay, or in this case, because we have the blue, we can replace blue as 1 minus the red. That's the one we're going to use here. Okay, so we can just say, instead of writing z greater than 0.4, we can say the blue region is equal to 1 minus the red region, and red is less than or equal 0.4. So 1 minus probability z is less than or equal 0.4. Okay, so that's the main point. Now all we do is just look at table for 0.4. So I'm going to open up now. So where's 0.4? So here's 0.4, so it's like 0.40, so 40, and that's it. So you get 6554. So it'll be 1 minus 0.6554. Yeah, and that should give you 3446. So the solution would be 0.3446. Okay. Another way you could just do this, if it's greater than and you want to flip it, just 1 minus it and then switch the sign. This is identical to that. Okay. Okay, moving on to part B. So it says that the company has a large store of samples analyzed by Yuto with the time taken for each analysis recorded. Now, Serena's investigating the samples that took Yuto longer than 50 minutes analyzed. Okay, so that's what we're looking at now. Now, she selects at random one of the samples that took Yuto longer than 15 minutes. So, okay, so this is already telling us that we're working in 15 minutes. So the sample size would be at least over 15 minutes. Find the probability that this sample took Yuto more than 20 minutes analyzed. Now, I don't know if you guys can see, but this is a straight up given that style question. Okay, so we're looking at the given that style problems. Now, how do we know it's given that? Firstly, we know straight away that Yuto has already did it. One of his samples took longer than 15 minutes, so that's already done. So if we were to solve this probability now, be it find the probability that sample took more than 20 minutes, or this should be the probability that it took longer than 20 minutes over 15 minutes. That's really what they're asking here. So probability he took longer than 20 minutes, given that that he already took at least 15 minutes. So we're finding like the probability of being over at least the time difference. Okay. And well, we already solved the first one. we already had 0.3446. Now we just work out the z value of this one and pop it back in. So same thing applies. So just like you did earlier, so just be probability of t greater than 15, so be z greater than 15 minus the mean over the standard deviation, which was 5. Okay, put that in the calculator. So 15 take away 18 over 5, you should get minus 0.6. So probability z is greater than minus 0.6. Now if it says minus there, you just pop it outside and call it 1 minus that probability you just did. That's the easy way to convert it. And again, to convert this back into the less than or equal format, using the idea of the red and blue, you can just replace this one with 1 minus the less than the equal sign, so 1 minus the left side. So then this probability now, let me just get more space, would be equal to 1 minus, and then just put one fat bracket, 1 minus probability that z is less than or equal 0.6. So actually, 1 minus 1 minus all of this cancels out, so you're actually just getting a probability z less than or equal 0.6. Well, it's getting kind of slow to load, isn't it? So yeah, actually this is reduced to that. So what we do now is go back to the table, find the 0.6 value here, and see what that gives us. Or look for z being 0.6. So let's see, where's my tables? Okay, so here's 0.6. So it'll be 7257. 7257. 7257. So this would be over 7257. So this will make more sense when you solve it. So really we're just finding the probability that, given that he took longer than 15 minutes, that he also took 20 minutes longer on this run. Or at least he took longer 20 minutes out, given that we know he took at least longer than 15. So it shouldn't be a very big difference probability. So smashing that in, we should get, well, about nearly half. Yeah, this looks like, so about 0.47 and round up to 249. So keep it 4 decimal places like the rest of them.